So like.
Half isn't overstated.
Like receive. And then it's EI. No, but there's like a lot of words that are EI, but. Well, I for E because drop it. The sound is A like neighbor.
What? I am confused on what that is.
I before E, except after C.
This is why I'm broke.
Hello. Yeah, I have stuff for you.
I've never heard that
Yeah,
before.
one like
As soon as you want, I'm here before, after, and during.
I love that.
Gotta get your TR and IR verbs.
guys, I need to get that.
Write that.
Day one.
Oh no.
Day one.
All right. As soon as that bell rings, you're done writing and in your seat. That's the rule.
You're just upset because I'm on a 7-day chain right now. Seven
Wow.
It's been a week.
Wow. That is why I'm upset. I woke up this morning and I was upset and I didn't know why, but now I know.
I felt that.
You like that
Your
jersey
second
last
one
night?
had to
Yeah,
I'm so upset.
reasons
Oh,
to
dude.
cry.
Right there on that shoulder was so much. Yeah, because I didn't realize I was bleeding until I just like swallowed myself.
I love you.
Reasons to cry. Not football.
Wait, no, right? I'm constantly being compared to my sister.
that's hilarious. So funny.
No.
Okay.
No one knows who that is.
Chill, man. Chill. Recycling bins have feelings too.
Yes, they are.
I saw my
All right, it's time. Sit down. All right, nerds. The day of reckoning is upon us. Your quiz is tomorrow. I swear, if you do not study for this quiz, you will fail it. It will happen. So if you're thinking, oh man, I'll study for Spanish right now, it's not going to go well.
It's gonna be like mostly like the quiz.
Pretty much, yep. So this is what we did yesterday, right? We identified whether the centers were inside, outside, or on the triangle and where they were, depending on which triangle we're talking about, right? Whether it's acute, right, or obtuse. We have 4 different centers that we need to know. We've got the in-center, which is the center of a circle that's inscribed. We have orthogonals, which just produces a bunch of similar triangles. And the reason for that is because if you look, these 2 green triangles right here, right? And again, you don't need to jump to this. I'm just reviewing, and then we'll get into the actual review. If you look, these 2 angles right here are vertical, right? And so that means they're congruent. And since these are all right angles, this triangle here has a green angle and a right angle. This triangle here has a green angle and a right angle. So what are they? Similar, right? So just by looking at the vertical angles, you can tell which triangles are similar when you draw the orthogonals. Like, these both have purple angles because they're vertical, and 2 right angles. So they're going to be similar. Same thing with these blue triangles. They both have vertical angles here and here, right? There's an X there. So those 2 angles are congruent, which means these are similar as well because they've got 2 angles that are the same. So orthogonals have some interesting properties that we're not really going to get into because it really gets complex. It's a very deep rabbit hole. For now, all I want you to know is that the crisscross triangles are always similar, right? In the acute triangle. Perpendicular bisectors form the circumcenter, right? That's the center that circumscribes the triangle, right? It's the center of the circle that goes all the way around the triangle. It connects the vertices of the triangle up. And because that's a circle, we know that the distance between G and any of our vertices will be the same, right? Because those are all radii. And then we learned about medians, right? Medians are vertex to midpoint. They make the centroid or the medicenter, whatever you want to call it. I usually call it the medicenter because it sounds like medians. It's the center of mass. And of course, the center of mass is always inside the object you're trying to balance, right? It's not going to be off the object. And the relationship between the segments here are always 2 to 1, right? So, behold, on the review packet, you need one. Little Shoni, get up here. Right here for you. All right, so these segments, AE, BF, and CD. What kind of segments are those? Say again? Perpendiculars. What else can we call them? Altitudes. What else can we call them? Orthogonals. That's my favorite one. And then the last one are heights of the triangle, right? So I'm going to write orthogonals, but all those would have been acceptable. Right? They're only perpendiculars. That's all we know about them. Right? They're not perpendicular bisectors because they don't cut anything in half as far as we know. So if those are orthogonals, where they intersect produces point G. G must be what?
Orthocenter.
The orthocenter, right? The place you go to get your orthodontistry done, right? Rip cow cash. All right. Or cash cow. Dr. Cash Cow. All right. So the orthocenter. When the triangle's acute, well, that's an acute triangle. Where's the orthocenter located? Inside. Very good. When it's a right triangle, don't memorize this. Think about it. Draw yourself a little right triangle. Remember, the orthocenter is the intersection of the perpendiculars. So if I was to go from this vertex and draw a 90-degree line, wouldn't it literally be this line? And wouldn't it be from this vertex, this line? So where are they going to intersect? On the 90-degree vertex, right? If you drew the last one in, it would be like this, right? And there's the 90, right? They all intersect at that point. So it's on the 90-degree vertex. And then if it's obtuse, okay, so we went from inside the triangle, and as I made that angle wider, it started heading this way. Where's it going to be when I make it obtuse and stretch that angle even more? It's going to continue along that path from inside, right? And as I stretch it to right, it moves to here. As I stretch it even further, it's going to move further out, right? So it's going to be outside the triangle. So what it's going to look like, don't just say outside. Make sure you know which outside. It's behind the biggest angle, right? That's where it'll head. It'll keep pushing out towards this direction. So this is the direction it heads. It goes from acute, inside, to further out as I expand that angle, to further out as I expand that. So it is outside. And there's the picture. I haven't decided tomorrow how I'm going to ask you about that question in particular. Right? Right now, it just asks where, and outside's good enough. But I will need a distinction. Okay? Yeah.
Do we have to write the words and draw the pictures, or can we just draw the picture?
For the last part right here.
Or just fine?
Drawing pictures is fine. I'll accept that. All right. So, any special properties? Well, the orthocenter doesn't really give us anything really that cool, at least as far as we know. But what do we know about it? I just covered it a couple seconds ago, a couple minutes ago. Or Shelby, do you have a question?
Yeah, I have a question.
What was your question?
Is it going to be like the same for every one of those? Like,
Pretty much.
If it was an orthogonal and orthocenter, then those would all be the same? Like inside and then outside?
Yeah, so for whenever you draw the orthogonals and they produce an orthocenter, right? For any acute triangle, it'll be inside. For any right triangle, it'll always be there, right? And for any obtuse triangle, it'll always be outside behind the biggest angle. That's always where it'll end up. And the reason that it's outside is because the height of this triangle is kind of like this, right? It's as if this was the ground, right? So the height from there to there. So it ends up pushing it outside. All right, so what special properties do we know about these triangles? You can mark it on the diagram or write it below. I'm going to mark it. Anybody see any vertical angles? Yes, right? So these two angles are vertical, right? We've got an x here. Ignore FB for now, but we have an x. So those two angles are vertical. And if these are right angles because of linear pair, then aren't they similar by AA? So this is similar to that. I'll accept that as saying they're similar. Little squiggle, right? Like the sponge. These are vertical, right? So since this is a right angle by LPT, these must be similar. And then lastly, these are vertical. So because those are right angles and those angles are congruent by AA, they must be similar, right? And then all the properties of similar triangles occur. So those sides will all be related.
So that's like all you have to do for
Yep, that's a special property for orthogonals. There's not a whole lot with orthos. I mean, once you get really into it, there's a whole lot. It's kind of like dentistry school. It's pretty boring. Teeth. You could be a doctor of the entire body, but you're like, no, I just want to know about the teeth. What kind of freak do you have to be? Just kidding. All right, number 2. What kind of line segments are those?
median.
Medians, it's vertex to a midpoint, right? Medians. That's when they're midpoints and perpendicular, right?
How is that vertex to a midpoint?
Vertex is A, midpoint is E, right? Isn't that a midpoint of the side, right? Vertex B, midpoint F. Vertex C, midpoint D. Everybody seeing that? Medians. Now, I always call it this particular thing, I call it the medicenter because medians, medicenter, it goes together, right? But you can call it the centroid. That's your God-given right as an American. Most of the Eastern Europe calls it a medicenter. Whichever you want is fine. For special properties, isn't the centroid or the medicenter the center of mass? You can write it down there, write it up here, I don't care. And then we also know that these segments, this guy right here, will always be twice as big as this guy. So it's a 2-to-1 ratio. Two to one, always. So if this segment were 6 GC, how big would DG be? 3, right? If this were 6, this would be 3, right? It's always a 2-to-1 ratio. The simplest way to show it is 2 and 1, right? And that's true for all of these. Now, this is the center of mass. Will the center of mass ever be outside the object we're trying to balance? No. If I'm trying to balance a stapler, where's the balance point? I don't know, maybe somewhere in here, right? But it's never going to be like here, right? Like, that's a really bad job of balancing. So if this is the center of mass, which it is, will it ever be outside the triangle? No. It's going to be inside the triangle all the time. Again, don't memorize, think concepts. It's the center of mass. Will it ever be outside? No. Done. No memorization needed. You don't have to think. Centroid, okay, it's inside for the acute. It's also inside, right? Center of mass, always inside the object, right? Through the page. These guys, they're examples of what? Yeah. Right, because they bisect the angles. They cut the angles in half, right? So of course they're angle bisectors. I hope you're starting to have these moments where you're like, of course that's what it is. How could it be anything else? That's how math should feel if you really, really get it. Angle bisectors. So the angle bisectors all intersect at a point G, and we call that point what? What center is that? The in-center. Now, this has a lot of properties. Namely, it's the same distance from all the sides of the triangle. So if you were to measure from here to here, remember, we always measure at 90 degrees, right? If I'm going to measure my distance from my head to the ceiling, I want to measure perpendicular to the ceiling. Right, ceiling's going this way. I'm going to measure perpendicular to that. I wouldn't measure like this, right? That'd give me a bad measurement. Like if I'm going to compare my height to Bo, I wouldn't go, look, we're the same height, right? I would go straight back. So when we measure to the side of the triangle, we go at 90. Does that make sense? So from here to here, this looks really close to 90. And then this one's almost exactly 90. I think that's more like 90, right? And all those distances will be the same. Right? It's the same distance from every side. We call that equidistant, right? It's equidistant to the sides of the triangle. Now, if we have a point, and we draw a bunch of lines from it that are the same length, here's a point, and I draw a bunch of lines from it that are the same length, what do I get? A circle, right? They're all radii. So there must be a circle here. And since the circle is only big enough to just perfectly touch one side at one point, right? The circle's going to fit perfectly inside this triangle. So draw that. So the in-center is the center of an inside circle, right? An inscribed circle. Scribe means to write, in means inside. Cool. How do we feel about that? Now, if it's the center of a circle that's inside the triangle, right? The circle's inside the triangle always. Will the center of that circle ever be outside? No, right? The circle's in the box, so the center of the circle will be in the box, right? So it's always inside. Cool. That's that. All right, this is the one you've been waiting for, the complex one. It's not just perpendicular, it's not just bisecting, it's a perpendicular bisector. It goes from the midpoint, that's the bisecting part, right? And then goes from there at 90, that's the perpendicular part. These are not heights of the triangle, they're just, hey, I found the midpoint, I'm gonna go straight up from 90 from there. Where they intersect, oh, first of all, let's write perpendicular bisectors. Perpendicular bisectors. And the center they create, if you look, is not equidistant to the sides of the triangle, right? I measured a 90, right, to the sides. That's what we did last time. And look, those aren't the same length. So that's kind of a hint. It's not the in-center. What center is it? Circumcenter. And the reason for that is that this center right here is not equidistant to the sides. It's equidistant to what? The vertices, yeah, the vertices. There's a radius, right, from G to C, and from G to B, and from G to A, which almost is exactly this line. It's kind of annoying. So those will all be the same. Right? Now, if we have a point with lines coming out of it that are all the same length, what do we really have somewhere? A circle, secret circle! It's a big one. And it hits all the vertices. Right? A circumscribed circle. Right? Circumscribe, like circumnavigate, to go around. Like Magellan, the first to circumnavigate the globe. Nope. He discovered. No, not really. It was already discovered. Literally one of the worst human beings in history. Screw that guy.
Why does he get us on holiday? He's useless.
Because colonialism and white power is something that we celebrate in America.
Yay.
Not in here, though. Screw that guy. He sucks. All right, center G. We call it circumcenter, right? Happy Black History Month, everyone. Where will G be located? If the triangle's acute, right or obtuse? Well, if it's acute, it's inside, right? Spoiler, everything's inside when it's acute. For a right triangle, we want the point that's the same distance from the vertices, right? Right here. It'll be the same distance here and here, right? Perpendicular bisector, think about that, right? And from here to here will be the same. So it's going to be in the midpoint of the hypotenuse. Does that make sense? Hype. HYP. Thank you. All right, and so following that route, right, we start out acute, it's inside, and as I make that angle wider, it pushes it away from that angle, right? And as I make it even wider, it's going to continue to push it away, right? It's going to continue following that route. So it's going to end up outside the triangle. So here's my obtuse triangle. It's going to push it out this way, right? Notice that the circumcenter ends out across from the largest side, right? And our orthocenter ends up behind it, right? When it's obtuse. Does that make sense? the widest angle, this guy's behind it. But for the circumcenter, the widest angle is in front of it. It keeps pushing it out further away. And the reason for that is that we have perpendicular bisectors, right? That's where we'll push it to. Right. How you feeling? Okay. This is the heart of the quiz. Knowing this stuff. If you see the bigger concept, if you understand one idea, it kind of gets you all the others, right? These are perpendicular bisectors, right? And I know that this is going to be the same distance from the vertices. Okay. If it's the same distance from the vertices, I have a circle that goes to the vertices, right? Circumcenter. Circumnavigate. What? Nope, I did most of it on the diagram. Could I write it? Sure. Like that is a circumscribed circle because it's the circumcenter, right? Scribe means to write, circum means to go around, right? In center, it's inscribed circle because it's inside, it's written inside the triangle. Cool. All right, let's look at this. Mark each diagram. So they tell you that G is the circumcenter. So what does that mean about G? It's the center of what?
Mass.
What? Perpendicular bisectors, that's one thing. Not mass, that's the other one. So let's find the bisection, right? The midpoints. Should all be like here. Let's draw those in. So like this. Perpendicular bisectors, 90 degrees from there, and 90 degrees from here. So we got perpendicular bisectors all around. Cool. All right, what else do we know about G? If it's the circumcenter. You can peek. Take a look. We just did circumcenter. What? What else do we know about G? What else can I put in this diagram? It creates what? Radii. To where? To the sides or the vertices? Yeah, the same distance from G to C, from G to B, and from G to A. Which means we have a circle somewhere, right? It's the circumcenter. Where's that circle going to be? Yep, outside, connecting all of our vertices. Done. All right, so number 6, G is the orthocenter. What lines make the orthocenter? Orthogonals, right? So just 90 degrees. So from the top, drop down. It's like the height of the triangle, right? So it's going to be C straight down to the other side at 90. So that's 90, right? And you can rotate the paper to might make it easier to see the heights, right? So I'm going to rotate it so BC is my base. And now I'm going to make the height of the triangle here. That's 90, so says me. And then the last one, I'm going to make AC my base. And do the height of the triangle from there. Something like that. So those are my orthogonals, right? And then this is the one where we get the vertical angles and get similar triangles, right? So this right here is vertical with this angle, right? So these are similar. These two are vertical. So these are similar. And these two are vertical. So these triangles are similar. The orthocenter is like a psychedelic party. At least that's my experience with the orthodontist. If they ask you if you want the gas, the answer is yes. 7. Ready? No. The in-center. What lines make the in-center? Angle bisectors, that's right. So we need to bisect these angles. So we go from the vertex to G, and it should bisect the angle. So when I draw this line, right, it cuts this angle into 2 equal pieces, so I can label that, right? And I draw this line. I know that this must be an angle bisector as well.
So all of them always go through G.
Yep, that's the point. Haha.
That's really.
Wow. I think we're going to spend today critiquing high school humor. We'll just go through TikTok and find all the ones that are most liked.
I guess.
You guys have terrible taste.
The underground ones are like artist people.
All right, so those are all angle bisectors, right? They must be. If that's the in-center, the line from the vertex to G should be an angle bisector, right?
Wait,
Yes?
how come 2 of them you made them go out farther than one of them you did?
You can do it farther if you want. The reason I do that is so you don't think that it hits a special point on the side, right? It doesn't necessarily cut the side in half. We don't know, right? Don't care. All right, so the in-center is the center of what? Not of mass. A circle. That is inscribed or circumscribed? Inscribed, right? So that means it must be equidistant to the sides, right? So the distance from here to here, and from here to here, remember we measure distance at 90-degree angles, and here to here, must all be the same. So these are all the same. Which then makes our circle, right? Yay! Isn't it beautiful? I think it's kind of cool. Like, it's just like, let's draw the angle bisectors of a triangle. Oh, look, they intersect at a point. That's really random. Seems to do it always, no matter what. Oh my God, it's the center of a circle that fits perfectly inside the triangle. Like, what? Why? That's random. It's the same distance from every side. Who would expect? Unexpected geometry is the best geometry. All right, centroid medicenter. This is the one y'all love. The medians are what? How do we make a median? To what? To midpoint. So let's find the midpoint of our sides. Here's our midpoints. I always draw my midpoints first if I need.
Oh, it's just in the middle.
Yeah, it's an estimation, right?
So
And then we go vertex to midpoint, and it should go through G, right? Vertex to our midpoint. Vertex to our midpoint. Cool, cool, cool. Those are medians. And then there's there's 2 cool things. One, center mass, right? I don't think there's a way to really show that with a picture, so I'm going to write it. Okay. G is center mass. And then what do we know about the segments? Like the medians, there's 2 segments. There's GB here and there's this G other thing, right? What's the relationship? 2 to 1, right? So like this segment right here will always be twice the size of this segment. And you can do that for all of these, right? Like this is twice as big as this one, that's twice. Doing it for one of them is enough. Okay? But they're all having 2 to 1 relationship. Will they all be the same length? No. But they're all going to be half and double. So if this is 2 and 1, maybe this is 6 and 3, maybe this is 8 and 4, who knows, right? But they're always going to be a 2 to 1. How are you feeling? It's going to take some studying because you need to know this stuff. But I don't think the concepts are hard, right? It's not like, oh my God, I'll never understand this. This is a lot of information and I need to know it.
This is only stuff on the text.
That's it. Let's look at number 9. I'm giving you a weird looking one. They're saying, given this diagram, what center must that be? Look at the lines that I made to make the center. What kind of lines? Perpendicular bisectors, right? Because look, bisector, because it cuts this side in half, 2 equal pieces, right? And don't they also hit at 90? So those are perpendicular bisectors. So what center must G be? Circumcenter. So we've got perpendicular bisectors. That's shorthand for perpendicular. we've got the circumcenter. And that means there must be a circle that hits all these points with center G. It's obtuse, so no wonder it's outside, right? Just to hit all those points, I had to go real wide. And G is equidistant to the sides or to the vertices? Vertices, right? So from G to B, it's the same distance as G to C. It's the same distance as G to A. They're all radii, right? If there's a circle, they're going to be radii somewhere, right? How you feel?
This is going to be my worst quiz I've ever taken.
Me too.
You know, it's just
I told you, it can be the hardest one or it can be one of the easiest
Let's
ones.
just lay it towards the easier side.
It can be. You need to study,
Am I going to
but you'll be okay. It's not memorization. All you need to know is that what circumcenter means, right? Circumcenter means to circumnavigate, right?
No, I didn't know. I didn't memorize all of that.
And the rest follows. What does perpendicular bisector mean? It means to hit it at perpendicular and to bisect, right? The hints are in the words. If you know what the words mean, you'll be fine. It's not memorization of the definition, because that's like if I made up a word, like Hakuna Matata, and I was like, it means no worries because I said so, right? It's like, okay, I had to memorize that. But if you know what the word means, circumcenter, circumnavigate, right? Then it makes sense. Circumnavigate the globe. Go all the way around. Go around the triangle. All right, moving on. 10. We've got triangle ABC. I know we have another triangle that kind of forms over here. The triangle ABC is what we're looking at. Okay? We have these line segments, CG and AG. What kind of line segments are these? Looks like they're perpendicular. Are they also bisectors? Bisect means to cut in half. Is that a midpoint? Not labeled as such, right? That's definitely not a midpoint, right? So what kind of segments must we be looking at? They're just perpendicular, so we can call them perpendiculars. Or what's the fancy word? Orthogonals. And the orthogonals produce what center? Orthocenter. So G is the orthocenter. And what's cool about G is that it creates similar triangles. So we know these triangles are similar. So like these two angles are vertical, right? So shouldn't these two triangles be similar? Right? Now the rest we don't have vertical angles for. So I'm not going to label them similar. I won't make you guys do it. Turns out these will be similar, but I won't make you do it. Cool?
Oh my gosh, there's more?
Hold on. Stay on 10. Do you guys see this big triangle here, GAC? And you see the big triangle here? Doesn't this right here have to add to 180? And doesn't this right here have to add to 180? Right? These two angles have to be the same.
The line is the same too.
Therefore, these are similar. I'll leave it at that. I won't make you draw the other ones out. Because there's a third pair here, but we'll leave it at that. All right. What are you talking about? Yeah. Yeah, I use different colors. You should use double lines. Yeah. All right, 11. All we know is that we have this dot in the middle. We're going vertex to an opposite side. Is that a midpoint necessarily? No. But what's the relationship between the pieces? 2 to 1, right? These must be medians, which means G must be the what? Yeah, medicenter or centroid.
I know, because I don't know if I do this.
Right. So this must be what? This point right here. What point must this be? A midpoint, so let's label it as such. And this must be a midpoint as well, right? The other one they didn't draw in for us, but that's okay. That's it. 12. All we know about 12 is that the distance from G to the opposite sides is congruent, right? So we have radii, right? So these lines right here are radii, right? But the lines that create G are perpendicular bisectors. So this must be the incenter, right? So we can draw this in. And then we know how to create the incenter, right? It's the perpendicular, or the angle bisectors, right? Because the last one didn't have a circle. Incenter and circumcenter do. So that must be an angle bisector. And this must be an angle bisector. And then B to G must also be an angle bisector, right? And you can draw them through the triangle if you want. It doesn't matter. They don't have to stop at any point. You can just keep drawing them through. I like to do that because it's easier to identify them. So we'll use purple, I guess. So this angle is cut in half. Something like that. And of course all these are right angles. So we've got angle bisectors, right? And then we have an inscribed circle, so we have the incenter.
What did you write in there about tiny
This angle right here is bisected by this line, right? Yep, so I drew a line from B to G, and because that's the incenter, I know that that must be an angle bisector, right? Because if that's G, it should be the intersection of angle bisectors. So there should be angle bisectors somewhere, so I drew them in. So we have an inscribed circle. Just for reference on this one, make sure you write circumscribed circle. That's number 9. Just tell me what that circle is, right? It's a circumscribed circle because it goes outside, circumnavigate, right? Mm-hmm. And that's that on that. I feel like inscribed and circumscribed go together, kind of, right? They're both circles. One is equidistant to the sides. Which one's that? Which center is equidistant to the sides of the triangle? Inscribed circle, right? Or incenter, right? Which one's equidistant to the vertices? Circumcenter, right? Because it circumnavigates, right? It's going to hit all the vertices. Right? When we measure distance to the sides, right, we need to go perpendicular, right? Median's medicenter, center of mass, right? 2-to-1 ratio of the parts. And then the weird one's the orthocenter, right? Which makes sense because orthodontists are usually weird. Cow and cash. Cash cow. Oh no! It's like he planned it that way. That's why vouchers are dumb, guys. We'll get into this later. But in general, vouchers are dumb. Would you rather have cash or a gift card? What is always better? Always cash, because it can go anywhere, right? Which is why vouchers are dumb, because they're like, here's this money that you can only spend at one place. We would rather have cash. So when you hear people talking about school vouchers, you can use your money where... Nope, nope, don't do that, don't do that. You'd rather have the cash. All right. So that's that on that.
You should help us study for Spanish.
Kumbaya, my lord. Kumbaya. What if I taught you French instead? Would that help?
I mean, I do.
If you have a checking account there. they won't be very nice if you just go to any bank to do it. Advertencia. Advertencia. Él no acatar todas las advertencias y instrucciones puede causar lesiones graves. No quite este bolsillo ni descarte las instrucciones que contiene. Lea todas las instrucciones completamente antes de ensamblar o de usar la silla. Si la silla no funciona adecuadamente, that's a new word, I've never seen that one, adecuadamente, o tiene piezas sueltas, faltantes o rotas, descontinúe inmediatamente el uso de la silla.
Can you use my flashcards
No.
now?
So loud.
There are two ways this quiz can go. It can be literally impossible if you do not study, or it can be one of the easiest ones if you do.
I'll study, but I won't do well.
Well, then the good news is that you know exactly what, like, there are no surprises here. There are no trick diagrams, there's no, you know what I mean? Like, in general, it's, do you know it, right? Or do you not? And if you don't know it, then you'll know what you don't know, and you should study that. That's the key.
I'll try to. Really, are you on the golf team now?
I'll study, but I don't have
Wow.
Nice. Kobe. So, the key to understanding this stuff is not to just memorize it blindly, but to understand the concepts. To see the big picture. I've got vertical angles and right angles. That's all I've got. Similar triangles. That's enough. That's all I got, right? There's no other information I can draw out of that. Orthogonals, orthocenter, right?
I want that.
90-degree triangle, intersection of the 90s, well, it's going to be there. Intersection of the 90s for this guy, well, it's going to be outside because the height of the triangle is outside the triangle. I think a lot of people get weirded out by that one. When you have an obtuse triangle, have you ever seen a diagram like this? Where it's like, here's the height, and they have to go outside the triangle to do it. Right? And that's because if this is the ground, that would be the height of the triangle, right? The height wouldn't fit here. It goes higher than that. So they put it out here to show you that it's measuring from the side. So imagine a weird looking building, right? This is the ground. And the building has an awning that sticks out. Well, the height from the awning to the ground would be this. That's the height of the building. So when we have an obtuse triangle, the height's going to be outside. So the orthocenter will be outside.
You know how I don't like that.
We got a couple minutes left. Vertex to midpoint, what kind of line is that?
Median.
Median, right? And they intersect at the medicenter, or centroid.
I'm never gonna.
And it's always inside. Why is the medicenter, ladies, shut up.
Are we still doing that?
Yes.
Sorry.
The medicenter, why is it always inside?
Because of gravity.
Because of gravity, it's the center of mass, right? The balance point on an object. No matter what object you have, the balance point is going to be somewhere on the object. It's not going to be here, right? That's a terrible balance point. Like, you might be really bad at balancing objects, but you're not this bad, right? To guess that, oh, maybe it's over here, right? No, that's not how it works. It's going to be somewhere on the object, and if it's really well balanced, it'll be right in the middle, right? Oh no! In center, equidistant to the sides because it has a circle inside, right? Angle bisectors make it. That's the kind of the weird one, I think, right? Angle bisectors make the in center. That's kind of a weird thing to connect. It's very unexpected that the angle bisectors would do that. But it's always going to be inside. Why? Why is the in center always inside? Because the circle's inside. If you have a circle, you're going to have radii. Don't forget to draw them. When we measure something, we measure perpendicular to it, right? So there are going to be right angles in there too. And then the circumcenter means circumnavigate, so go all the way around the triangle, right? Like go around the world, like Magellan. Trapezoid?
Traffic light.
Oh, traffic light. Are you guys more concerned with Spanish? Because if you are right now, I understand that because you have a quiz coming up.
Heck no.
However,
I'm so stressed.
let it be known, I will have no mercy upon you. None.
That's all I'm doing tonight is this.
Good. If you do not study, I will have no mercy upon you.
I will study. I'm going to study and try my best.
Do,
I'm
and
honestly
I would.
probably not gonna study.
That's fine. But I would encourage you to make sure you know this stuff really well, because next week I'm going to assume you know these terms and what they mean and what all the information you get from them, and we're going to be doing proofs with them. You'll get a triangle and it'll say G is the incenter. Prove this, right?
When are we gonna get to the easy stuff?
That's just how it be sometimes.
I know, but it's only 2 days, so I feel
2 days for 4 things. First hour uses their time really poorly, so that would make sense.
When are we gonna get to do easy stuff again?
If it was easy, why would we be
There
doing
was
it?
ever easy stuff?
Yeah. When was the last time we
Beginning
had
of
easy
the
stuff?
semester, or first semester?
That was the hardest thing for me. No.
Looking back, it's easy, right? Kind of like when you look back at 3rd grade and you're like, how did I not destroy that class, right?
I was talking with my little sister, and she was doing like the distribution, and it was like 4, and then times like 3 plus 7. I'm like,
Exactly, right? Like, I remember when, but it was hard at the time because the number one thing, for better or for worse, for your understanding, is time. It doesn't matter how smart you are. That might diminish time's effect, but in general, it just takes time for everybody. It's not that it's too hard, it's just it hasn't sunk in yet. So spend some time with it so it sinks in. Like what we did with congruent triangle, side angle, side, and all that stuff, you guys were struggling at the beginning of the semester. But I think now you're like, oh my god. Look, there's 2 angles and a side. It spells AAS. I'm good. Right? They're congruent. Move on. Yeah, you guys struggle with that a lot. You're like, how many things can we skip again? You're thinking way too hard about it. Spend some time. And that's when you know stuff. Because over time it gets easier. It's not memorization. If you memorized it, what happens over time? You forget, right? That's the difference.
Hey.
Yeah.
I know exactly what you're gonna do.
All right, I'm bored. You took too long.
Name 3 things.
Would anybody like another quiz review?
I would.
You're not even going to study, so what's the deal?
No, I don't want that. Name 3 things that you use every day.
you're doing
And
5.
5, 4, 3.
Good.
Remember the beginning class, they're like, that's not funny? And then this is an example of what your humor is. You guys are all morons. And it's not a personal insult. You just don't have developed brains yet. It's a fact.
Wait, how old
It's
are you?
okay.
You just know we're gonna be
It's really okay. Yeah, you are high schoolers. You should be allowed to be high schoolers.
do it. These 3.
But I think objectively, you can say you are all dumb.
Hey.
Except for you. Right? Your brain's almost fully developed. You're on your way. Yes.
Name 3 things you use every day. 5, 4, 3, 2.
Whenever you give me the opportunity to show that you're not the boss of me, I
Now
would
notice how you didn't say geometry.
Right. Oh, great. Let's talk about that. Why do we teach geometry? Because it expands your brain. Just the same reason we teach anything. I'm not teaching you this because you're going to use it the rest of your life. That's a load of BS. If a math teacher tells you that, they're lying to you. We're here to expand your brain.
Okay, but
I'm here to give you an education, how to
It
think.
makes my brain shut down.
Then that means you definitely need to work on it. Because if your brain shuts down whenever you get anything new, you're really going to suck at life.
not when I get something new and I
Right?
get that I know what it is.
Right, but that's where the challenge is. We don't show you stuff. If we show you stuff you understand all the time, your brain never grows.
No, when I'm forced to know something.
No one's forced you.
Those grades are. Do you even have that?
Like, why do you care about it?
Right, because you want to.
Because I need to not have, okay,
Yeah, that's why we need to get rid of grades. Because folks should be on learning. Yep, and that's a load of BS. This is why I make it the way I do it here, because the grades really don't matter. 40% of your grade is basically free. Bye.
That was fun.
See you tomorrow.